Okay, welcome everybody to another MAE Speaker Series episode. So today we have our guest and UF alumnus, Dan Plonk. Dan Plonk is the Director of Transportation Application Planning for Norfolk Southern Corporation. Dan earned his BS in Mechanical Engineering in 1983 while a starting offensive lineman for the University of Florida, go Gators. He continued his engineering studies at the Georgia Institute of Technology, graduating with an MSME in 1985. And then he completed his MBA at Virginia Tech in 2001. In 1991, he joined Norfolk Southern Corporation, NSC, doing artificial intelligence work, developing highly acclaimed expert systems that simplified locomotive maintenance. Dan was named a director in operations in 2003, where his group was responsible for the systems and analytics that ran and monitored a 20,000-mile rail network. His group developed the world's first operational train movement planner, a locomotive fleet sizing model, as well as an optimizer for network-level train operating plans. In 2009, Dan led a group of peers to substantiate and achieve a dramatic halt in planned coal car purchases, thus avoiding over $300 million in capital expenditure. In mid-2015, he was tasked with starting NSC's first foray into data analytics, focusing initially on the 25,000 plus devices that make up the Rail Internet of Things network. So welcome, Dan.
All right, thank you, Dr. Brooks. So are you ready to blast off here?
Yeah, let's go. So Dan has a wonderful presentation for us.
Okay, I'm gonna start the broadcast here. You won't be able to see me, but you'll be able to see my presentation. How's that?
Perfect.
Okay. I've titled this thing Railroading 101, and then we'll talk about automation and our path in that direction. Railroading is fascinating. I'll have to admit, when I went and interviewed, I probably knew 1% of what you needed to know about a railroad. So I'm glad they didn't ask me any detailed questions, because I would have failed. Anyway, we'll blast off here. I got let's see, 30 minutes, and I'm going to time myself on this thing. Now, Dr. Brooks mentioned most of this. I graduated from UF in 1983. I did play football for 4 years. Just to shout out to mom and dad, a really interesting upbringing. My dad was military. My mom was a teacher. Both were athletes. I was actually born in Hawaii. We lived all over. We eventually, my dad went on to Korea by himself. We, mom and dad, my two siblings, we went to Merritt Island, Florida. So I'm actually from where the Space Center is. I went on to graduate school in two other locations, Georgia Tech and Virginia Tech. Met my wife while I was at UF. She's from Chiefland. So any of you who've been over to Fanning Springs, she lives over that way. 3 kids, Isabella, Paul, and Noah. I got my brother and sister are medical professional. One is physical therapist. The other one's a nurse. So I'm kind of the oddball here. I am a pilot quite a bit, and I fish more than I do hunt. So that's a little bit about me. Here's the presentation. I'm going to talk about notable North American railroads. We'll our network, customer segments. I'm going to talk about finance, a little bit of financial stuff. That's good. That's good to make that part of your capability. I'll talk about the primary components of a railroad. I got some pretty good pictures in here. I'll have to gloss over this, but I'll talk about the week in the life of a rail car, just so you understand how a rail car moves. I'll talk about a little bit of the evolution of railroading, stuff I just came up off the top of my head, just some other interesting facts, and then I'll get into the automation thing. My title, that's an old biography. My title is actually Director Automation and Innovation, so I'm fully into the automation thing. I did borrow some of these images. This is from the American Association of Railroads. If you look at the 4 railroads shown in the red squares, R being in the middle, Norfolk Southern, But the four big railroads in the United States are Burlington Northern, CSX. Of course, you guys being from Florida probably see a good bit of CSX. Norfolk Southern, then of course the one that has had the same name all along, Union Pacific, the lower left. The other notables are, you see Amtrak there up on the top row. That's a passenger service, by the way. Two of the best rides are Chicago to San Francisco and Chicago to Seattle. So if you can do that someday, that'd be neat. Canadian National, upper right, and Canadian Pacific over to the left here. Those are the two large Canadian railroads. I'll call out Genesee and Wyoming there in the middle, G&W. They are actually an international conglomerate of probably 80 to 100 short lines. So really small railroads with a parent company. That's Genesee and Wyoming. Pretty interesting setup that they have. Let's see, just an overview of our network here. We're in the eastern part of the country. I work out of Atlanta. You can see our rail there, and our major terminals. Those are where the little black circles are. We interchange to the Western railroads out of New Orleans, which you see in the lower left. Out of Memphis, kind of middle left, Kansas City, middle upper left, and then of course Chicago and St. Louis. So out west you have Burlington Northern and Union Pacific. We interchange trains, Chicago, Kansas City, St. Louis, Memphis, and New Orleans. And let's say you have a container that comes from China, it's offloaded in Long Beach, it goes on a Burlington Northern or Union Pacific train. They bring it to us at Chicago or Kansas City in general, and then we'll take it to Pittsburgh, New York, Atlanta. That's how railroads actually work together. Let's talk about customer segments here. I got those listed. Largest revenue contribution to leased intermodal. Of course, that's containers that you'll see, those multicolored trains there with the containers on top. We haul a lot of chemicals and even a lot of bad stuff, liquid chlorine and that kind of stuff. We haul a lot of energy stuff, mostly coal, but we do carry ethanol and oil to be converted to fuel. We do a lot of agriculture. We carry a lot of soybeans, corn, and fertilizer. We move a lot of really heavy stuff related to construction. We are the largest automotive carrier in the country. So we carry a lot of finished automobiles. And then, of course, a lot of forest products, lumber and paper. Just so that you know, and you can see the financial breakdown over there on the right. Intermodal, which is the upper right-hand corner, makes up about 25% of our $11 billion of revenue. These are 2019 numbers. Just so that you understand, railroads generally don't compete much amongst themselves. Our primary competition is trucking. One of the neat things about railroads is we tend to cooperate with each other. So whereas Coca-Cola and Pepsi, you could fuel a civil war out of that competition, that's not the way railroads work. Just some other quick financials here on the expense side of things. The biggest part of the pie there, the darker blue piece, that's compensation and benefits. That's about 38%. There are other pieces in there. If you see the yellow piece there, you're looking at about $1 billion for diesel to run locomotives. Another thing, and I borrowed this from actually New York University over on the right side here. Net margin is essentially a company's net income divided by its gross revenue. I took the top 10 and then some other select ones all the way up to in that list of 100 industries here. If you look at railroads, we tend to make some pretty good money. Now, a lot of that goes back into our network because we spend about $1.5 billion a year in our capital, maintaining our network, buying locomotives, that type of stuff. So railroads do net quite a bit of money, but they also put it back into the network to keep it running. Just some other numbers here. I won't quote all of these, just some interesting ones. And I'll show you some really good pictures of bridges. We own all those. We don't necessarily build them. We may have in years past, but those are 10 to $50 million enterprises. Locomotives are 2 million. Rail cars are about 85,000. If you look at the average wage and benefits, that's probably a good bit better than average for this country. So if you're willing to work hard, and I'm not talking about being a mechanical engineer or an electrical engineer or being a civil engineer. If you're willing to be an engineer or conductor or a maintainer, an electrician type person, track inspectors, that type of stuff, carmen and women, there's some pretty good wages out there. Train dispatchers. We got about 20,000 route miles, operate in 22 states. And another one, there are 1.5 million rail cars in North America. And we own about 50,000 of those. I'm going to talk about the three primary operating departments: engineering, mechanical, and transportation. I'll also give a shout out to IT because it takes a lot of systems to run a railroad. Engineering is divided up into two pieces. We have communication and signals. We call them CNS. Most of those guys and gals are electrical engineers. Okay, anything that has electricity to it in the field, which would include signaling, switches, crossings. The lower left-hand corner there, that's actually a snow melter machine. They maintain that electrical stuff. The other half of engineering is maintenance away. Any of our heavy infrastructure, our track and the foundation, bridges, tunnels, those tend to be civil engineers. Okay, so if you look at the pictures to the right, in the right-hand column there, you'll see a double track tunnel. You see the track, the ties, the ballast, which is the rock as a foundation. The second picture down, you actually see where they're putting in new rail there. That's a pretty good picture. The third picture down is we were building a bridge in New York State to replace the old bridge there, which is to the left. And then the lower right-hand corner, that's the bridge over Lake Pontchartrain, which is north of New Orleans. That's the longest rail bridge in the world over water, by the way. Anyway, right side pictures are maintenance away, left side pictures explain CNS. So this is engineering. Okay, transportation, those are the people that actually make the railroad move. We have a network operations center where you have train dispatchers that actually clear signals, throw switches, and otherwise communicate with trains via the radio. We also have a PTC group, that's positive train control, and I'll talk about that a little bit more. That's actually a system. Road trains, trains that move, let's say, from Macon, Georgia, all the way to Elkhart, Indiana. Those are our long distance trains. Local trains are what you consider to be the first and last mile. You know, we pick cars up at a customer to get it into the network. When the cars get to the end of their trip, they're delivered by a local train. Then we also have quite a few people in yard service. Yards are where cars make connections from one train to another until they get near the customer, and then the local carries them out there to be delivered. Okay, so this is transportation stuff. Here are I'm looking at some of the bigger infrastructure here. These are yards. The top one being Decatur, Illinois. The one to the right there being Macon, Georgia. The one on the lower left is actually Savannah, Georgia. The map there shows some of our bigger yards. You see the one down there in Jacksonville, which is about as close as we get to Gainesville, except for maybe at Occidental. Yards are where cars make connections and their sorting done. We do have 2 yards actually in Florida out of the 250 yards that we have on our network. The one just north of Lake City there at West Occidental, and then of course the bigger one there in Jacksonville. Our largest yards, I got 3 of the pictures there, but there's also Bellevue, Ohio, which is our largest yard, by the way. Bridges, we're going back to engineering here. This is large infrastructure. all of the bridges, and we have many of them, they go over the Ohio River, the Mississippi River, the Susquehanna, big rivers across the system. Some of them not necessarily rivers, but in hilly territory. We own those and we maintain those. So any of these giant bridges, those actually belong to the railroad. So just from that, you can probably tell that our infrastructure is pretty pricey. Okay. IT is very important. Information technology is pretty important. Actually, I'm in IT. I used to be an operations guy, but I had an eye for systems, so I'm in IT now. Way billing, which is a initial request for car movement. Once you get a way bill, you create a trip plan. So the car will be picked up by train, a local, maybe GO2. It'll go to a road train, train 174, which goes making to Elkhart. Then it gets on another road train there on 19K, goes on down to Lafayette, Indiana. And then it'll actually get on a local down there at D93 to be delivered to the feed mill. So that's an example. We also have yard inventory systems called TIES, Transportation Yard Enterprise System is the acronym. We also, how we move our trains, we do that with a system called UTCS, Unified Train Control System. Very important system there. Actually, back when I had transportation systems, I had 3 of these 4. So everything but ties. So more important systems, positive train control. That's we finally said, you know what, we have too many human errors. We need a system that will stop the train. Let's say the engineer is over the speed limit or goes beyond a signal. The system will actually stop the train to avoid train collisions and train wrecks. We also have energy management. So if you can think of cruise control for locomotives, just like you have cruise control for cars, that's energy management. They save us about 10 to 20% on diesel because of the consistency of the train being run. We also have a transportation event processor. It's in-memory computing. It can do about 1 million transactions a second. We do quite a bit out of there. One of my automation projects, the controls for the automated snow melting actually run through the gizmo we call TEP. The last department, and this is where I started the railroad at, was in mechanical. So most of our mechanical engineers go into this department. You'll either be a locomotive person, and that's where I was. Here you see the 6 locomotives paint schemes for the 6 big North American railroads: Canadian National, then to the right of that, Union Pacific, then Norfolk Southern in the top right, lower right, Burlington Northern, middle right, Canadian Pacific, and then lower left, CSX, which, by the way, is headquartered in Jacksonville. Okay. I borrowed this picture actually from Trinity rail cars. This was a really nice picture of the different rail car types. Now there are others, but this probably makes up 90%. So we got probably 10% specialty and about 90% standard. You have tank cars, covered hoppers. Those carry grain, usually auto racks, which of course carry cars. Lower right, the old style box car, that was probably the original rail car. We have an open top hoppers and gondolas. You might carry wood chips and rocks and stuff like that in those. And then the lower left, there's the deep well cars where you would stack and double stack intermodal containers. So these are the car department side of mechanical and the locomotive side of mechanical. That's where mechanical engineers usually end up. Let's talk about trains just a little bit. Here's some really good pictures of trains. Some of those you'll see, for instance, like the lower right. There's a yellow and black locomotive. That's actually one of our heritage predecessor railroads, the Virginian. That was actually an electric railroad, believe it or not. But there's also several trains represented in here. You see lower right, that's intermodal. Upper right, that's actually a loaded coal train. That's actually going through downtown Roanoke. Upper middle, that's actually what we consider a mixed freight. We call them merchandise trains. Actually, the locomotive there on the front, that's from the old Pennsylvania Railroad, which is part of our railroad. That's one of the monopoly board railroads, by the way. And then upper left, that's an empty ethanol train going back. I know it's empty because there's only one locomotive on the front. It's going westbound, probably from Delaware back to North Dakota, where we received it from Burlington Northern. So that's an empty train set because there's only one locomotive on the front, but that would be an ethanol train. Lower left, that's an auto rack train going across the bridge there in New York State. And then the middle lower is actually a specialty train there. You'll see that's farm equipment. You see the giant combines and tractors. So we do haul a lot of heavy stuff. There's a lot of detail in here. I was going to go over the week in the life of a rail car. I mentioned it briefly, and I'll go over it briefly here. Let's say you have a car that's released empty up at the feed mill in Forsyth, Georgia. It's released empty. We need for it to go back to Indiana, so there'll be a trip plan that'll take it from Forsyth, Georgia, on a local to Macon. Then on Macon, it'll get on the road train 174 to Elkhart, Indiana. It'll make a connection there, and then it'll go out on 19K to Lafayette, Indiana. It'll be dropped there, and then probably a day or two later, it'll go out on a local, I believe it's D93, to be delivered to the grain elevator in Clymers, Indiana. And that takes about a week. Okay, so that's kind of a summarized version of the week in the life of a rail car. There's a little bit less detailed trip plan there, but you can see in the gray there, it went from Forsyth, Georgia to Clymers. GO2, 174, 19K, and then D93 were the 4 trains that it went on to get to the customer. I'll talk a little bit about evolution of railroading. Safety is pretty important for us because, as you might imagine, it's easy to get squashed with heavy stuff moving around. Over the course of the last 30 years, we've gone from 34 to 6 injuries per million train miles. So we've done probably about an 85% reduction. So safety being important, that's a great improvement there. Locomotive propulsion, just in case you didn't know, they originally were wood burning. Of course, I think we all know that they were coal burning. Where they are today are diesels. Diesels turn in an alternator. So you have a big marine engine that runs on diesel, turns a big alternator, which turns out alternating current. It's rectified to DC if it's a DC locomotive. If it's rectified back to DC, then back to AC for a different waveform, I guess. For AC locomotives, we do have some electric locomotives. They tend to be in yard service, and there are some that run on natural gas, not on our railroad, but Florida FEC, which is a Florida railroad that runs from Jacksonville to down to the Keys. They run a few natural gas locomotives. Locomotive outputs, believe it or not, steam engines were about 6,000 horsepower. Our diesels are 4,500 now. We used to have a caboose on the back of the train. All of you younger folks probably have never seen that. People my age probably remember cabooses. They've been replaced by the little, if you look at the picture over there to the right, that's an EOT, end of train device. That little electronic box does what the caboose used to do, and the caboose had 2 people in it. That's the rail gauge evolution. It started out at 4 foot 8 inches, flip-flopped around a little larger than that, but then it ended up at the 4 foot 8 standard. There's just a list of cars. Originally, they were probably all box cars, and actually, they used to shovel grain into a boxcar, and then they eventually invented the gondola, which was a much easier and faster way to load and unload a grain. Track, they used to be 10-meter chunks. Now we manufacture them ourselves in 400-meter chunks, and then we actually weld them together. So You won't hear much of that clickety clack that you used to hear back in the 60s and 70s. It's ribbon rail, continuously welded rail. It's about 130 pounds a foot. We used to run trains on train orders, which means they followed a schedule to a T, and you ran your railroad to that. Then we put in signaling in the 50s, 40s, 30s, 40s, 50s. We now use positive train control, and we're working towards virtual moving block. Communication used to be paper. Now it's radio and then actually digital to the locomotive on board. These are some interesting facts here. Rail is about 5 times more fuel efficient per mile than trucking is. Our busiest line is Cleveland to Chicago. One thing there at the bottom, if you go all the way to the bottom of this one, it says railroad retirees are covered by the railroad retirement system instead of Social Security. Actually, railroaders had their Social Security about a year before Social Security existed. Where rail needs to advance, there is some sense of urgency given trucking's motivation. Trucking has a 100% turnover of its employees every year, so they're working with tech companies to automate trucking. That could be very painful to us if we don't counter that in reduction of expenses and perhaps fuel consumption and stuff like that. We need to put sensors on rail cars. We don't have any of that type of stuff. We do know where they are when they pass by a scanner, but we do not know that a rail car actually suffered a huge load on it, perhaps from poor train handling. We need to do better performance against our original trip plans. We probably run about 70% there on the original trip plan. That's a C- in my book. Trucks are probably up there A-. One way we can counter that, we actually have the technology now in place where we can actually go from 2-person crews to 1-person crews. So we're going to start that path here soon. There's a nice picture of our heritage units. And so that's kind of railroading 101, what I referred to there. An awful lot goes into running a railroad. I could probably talk a few hours just on that piece of it, but that was the quick version. So we don't spend too much time talking about that. Let's talk about automation. Automation in general, of course, you're automating processes in a lot of cases. And of course, you got tech and IT and even mechanical things that get into that. They can be mechanical or virtual, meaning systems as opposed to mechanical devices. A good many activities are small duration but repetitive. Some are longer duration and cause fatigue and stress. In some cases, individuals they could spend their time better doing something else. We try to automate things to help people focus on higher value activity. I'll mention here in a little bit, I have some suggestions for people once you get into your career so you can get a little closer to the company that you work for. But in the end, we do this to improve processes, savings of resources. For instance, like the snow melting automation, we save about 1.5 to 2 million gallons of propane by automation. We also are able to reduce needed personnel to actually run the railroad. So I call that full-time equivalent savings there. So some of that does happen. I'm going to talk about some of the automation projects that I've been a part of. Some of these I've actually done myself completely. Others I've worked with IT to have these implemented, and then others in some cases actually external vendors. And I'll probably pick one off of each page here. The first one here, terminal inbound detail process. I worked at an engine terminal when I was a mechanical supervisor. Engine terminals are where trains come in, you pull the locomotives off, they need to be fueled and serviced. Generally, you like to keep up with what's coming and know if they have issues before you get there. Of course, back in the old days, you used to pull up the mainframe screen, put in your scanner codes for your area, write down the locomotives on the inbound trains, and then you would go into the locomotive system and actually look up open trouble tickets, the last time they were fueled, and that type of stuff. I was able to write a piece of software that used the mainframe emulator, did all that stuff automatically. It ran in about 2 or 3 minutes, and then actually printed out the report on a piece of paper. So for me, when I do something that is um, repetitive like that for about 3 days, I'm about to throw up because that hurts to do something that the same thing over and over again like that. So I wrote a piece of software to do that. Anyway, that's that saved quite a bit of time at engine terminals, probably 30 minutes a shift for individuals. We installed it at about 20 locations. So, that was a good success. Cheap to build. Another thing, believe it or not, we actually let other railroads run on our property. So Amtrak is a good example of that. They've run on our railroad from Washington, D.C. to New Orleans, Norfolk to, I believe, Roanoke, Dearborn, Michigan, which is near Detroit, to Chicago. There's quite a few trains that run through there. Canadian Pacific runs on us between Detroit and Chicago, about 6 trains a day. To simplify the exchange of trains, we have a process, it's called EDI, Electronic Data Interchange. 161 is a standard, where they transmit the crew, the consist, the locomotives, the details of the train, and it comes straight and goes into the dispatch system. So it's full integration. So rather than doing it the old way where you did it with a telephone and an email or faxes, it's all automated these days, and it saves the dispatchers the pain of having to do this thing on paper and fax and telephone. We also built the same kind of system where it says FTE, that's the foreign train dispatch there. We interface with a lot of smaller railroads. They don't have IT departments. We actually set it up where they can actually transmit their information via a user interface. And they get their train clearance back, and we don't have to do the fax, email, telephone thing anymore. Saves them a lot of train delay on their side, actually. One thing that I'll mention at the end, if you can learn to program, even though you're an engineer, you'll be able to solve problems that IT will never get to. For every big problem big project they do, there's 100 little ones that they'll never do. One of my guys, we built a system that was in a train device tracking system. We integrated the UPS shipping API. It's actually been in use for 20 years, and it's still in use to this day. There was actually a freight forwarder that helped us out with the manage of in a train device. We were able to do away with them, and it saved about $1 million a year. So that's a real savings, and all we did was write a piece of software ourselves and implement it. Also, probably one thing I didn't mention about the dispatch system, ours actually has, actually it was in my biography there, the world's first operational movement planner, where this computer comes up with the moves. So it knows how to move the trains and execute the moves. So the computer will actually do, if you can imagine playing chess against a computer, that's exactly what that is. The computer is playing chess with the railroad and figuring out the moves. With that, you also get ETAs, which is pretty important. That helps you actually get at the next crew change location. That helps you get the crew on duty right there when the train arrives, so that he's not sitting there for an hour or 2 hours waiting for the train to arrive, but you actually use the movement planner ETAs to actually order the crew on duty. We also have implemented, this is a project that my group got started about 5 years ago, the old process of submitting speed restrictions. Okay, so you might find a track defect and they'll call in a speed restriction. They used to make a phone call. course, that took time. Sometimes dispatcher was busy. Now they have a mobility app on their iPhone, and they can actually submit the speed restrictions remotely. So that it pops up for the dispatcher, he takes a look at it, hits the button, then it goes into the system. So that took a lot of work out of that cumbersome process. I'm also working a project to automate track inspection. Currently, we have 2 guys that ride in a high rail vehicle, which is a pickup truck with rail wheels. We're going to use a LiDAR, infrared, and optical. We're going to control our own lighting. We're actually going to do have a GPU and do the edge compute with that to actually do a better inspection. That'll allow us to go to one-man crews, and even at that point, you'll probably be able to run, instead of about 20 miles an hour, about 30 miles an hour. So the guys will be able to go on their own and let the computer do the inspecting. Eventually we want to evolve that piece of equipment to the back of the train and take it off the high rail vehicles. One that I did mention, this is one of my projects that was put into 2 winters ago, snow abatement, especially up north, let's say New York, New Jersey, Pennsylvania, Ohio, Indiana, Illinois, Missouri. They get a fair bit of snow. Well, if you get snow in a switch point, the switch won't throw because it won't compress the solid. We have propane melters out there. The dispatchers just turn them on. Hey, I know there's snow coming. I'm going to turn it on. Maybe 3 or 4 days later, turn it off. We were spending about $5 or $6 million a year. We actually use our in-memory computing system. Pulls the weather every 15 minutes, and it saves about $3 million a year in propane. So that's real savings there. About 1 to 2 million gallons of propane per year. Slide fences, of course, we have rock slides on our railroad. They cover our track. We're actually the current version is actually a fence. We're looking at virtualizing that using LiDAR, infrared, and optical, and that will do away with a lot of false positives there. And eventually we'll be able to do away with the mechanical fence. And we have about 400 slide fences, most of them in Pennsylvania, West Virginia, Virginia, and Ohio, where it's really hilly. The largest projects here, and I have these mentioned, and I'm starting on the top one next year. Yard automation. We have conductors and engineers in yards. We're actually going to work to take them out, and the locomotive will move itself to a switch list set of commands. You'll have a utility person on the ground that'll still throw the switch and occasionally do uncoupling and stuff like that. We're looking at significant savings there, about 30 million a year after tax. Local trains, because of the yard switching, we've developed with vendors the technology that can be applied to the trains that do the first and the last mile transport of a car. It allows us to go from 2-person crews to 1-person crews. And this is done by attrition. We just don't chuck 1,000 people. We allow people to attrition out over the course of probably 10 to 15 years. But there'll be significant savings there. The same thing applies for road trains because we have positive train control, which is where the train knows where it is. It knows the speed limits in the area. It knows, hey, I can go up to the next signal. If the engineer doesn't slow or stop the train properly, actually the system will take over. In reality, we no longer need the conductor on these trains, so they'll be taken down over 10 or 15 years from 2-man crews to 2-person crews. From a conductor and engineer to an engineer only. The dream, and I'm not so much of a fan of this, would be completely automating the process, where you have a pilotless train. I'm kind of melancholy on that. I think that's a tougher one to do. I would prefer to leave the engineer in the cab. And given that you have cruise control on the train, you have PTC protecting, perhaps the guy could go further. So instead of going, let's say 100 or 140 mile trip, he does a 250 mile trip. So he can actually, instead of going from Atlanta to Greenville, or let's say Atlanta to Macon, he'll go from Atlanta to Valdosta, or Jacksonville, instead of going from Jacksonville to Valdosta, Jacksonville to Macon. So that's on the last one. That's completely pilotless. You know, I'm fair with that. Well, Doctor, I got let's see, one more slide here, just to give you some advice. And of course, this is with plenty of hindsight. Okay, so because I've worked for the railroad for nearly 30 years, I am a mechanical engineer. Okay, so I took thermostatics, dynamics, you know, vibrations, fluid mechanics. I did numerical methods, controls, all of those classes that you guys and gals are taking and teaching. Because, you know, though I did mechanical stuff, I eventually ended up in systems. I was more in tune with the virtual area. One thing I did learn to do, I was fortunate I learned to program. And of course, I started out with Fortran, you know, 40 years ago, but I got really good at it. I've also kind of evolved to be more financial and understanding budget accountability. You know, I did take some industrial engineering courses, which introduced me to process improvement. I got to be really good at the lean technique there, leaning processes. And another thing, I actually got to be a facilitator, so I got to help people solve their own problems, which is that's a really good combination. When you can help people solve their own problems, that you get really good buy-in there. I was an operations guy, so to be an operations guy and then be a systems guy in IT, you know, I understand the railroad like better than probably 90%, 95%, or 99% of the people at the railroad. So you can really come up with good solutions if you understand operations really well. And so I was fortunate to start out on operations and then move to, let's just say, the back office systems, and then eventually to IT. Communication skills matter. You never know when you'll bump into the CEO or the chief operating officer or somebody who needs to be influenced. So get your elevator speech ready. Also be really good with the 10-minute pitch. That's generally when you're working with your coworkers. And then of course, be neutral or positive in emails. That's just a career advice item there. Okay. I didn't run over too much. Dr. Brooks, you want to take it from here?
I was muted. Thank you. Thank you for that great presentation. So we'll open up the show to Q&A. So we actually already have a question from Dr. Arakiri, and he asks, what percentage of freight is moved by rail in the US? Is it greater than by trucks?
Ooh, gosh darn it. That's a good question. Let's see, if you look at ton miles, because we do some really heavy stuff. You know, a grain car, there's 100 tons of grain in that car. Well, I think trucks might be limited to what, 70 or 80 tons on the highway. Of course, that includes the weight of the tractor and the trailer. From a ton miles perspective, I think we may be on top. But from a revenue perspective, I think they're on top. So we tend to haul really heavy stuff, pretty good distances. So if you can imagine a rail car full of stone, how heavy that thing is, imagine grain cars. I think gross ton miles, we might have truckers beat, but from a revenue ton miles, I think they got us beat. Okay, hope that answered your question.
So Dr. Arakiri has a follow-up question. So what is the fuel efficiency for moving freight by railroad per ton mile relative to diesel trucks?
Right. Well, the way we measure it is of course, we take the total ton miles divided by the number of gallons we do over the course of a year on fuel. And we can move 1 ton of freight. This is a little bit different than the question measure. We move 1 ton of freight 470 miles on 1 gallon of gasoline. Okay, and I think trucking is under 100.
Mhm.
Okay, so and it may even be closer to about 80. So for trucking, I'll say they can move with 1 gallon of diesel, they can move 1 ton of freight 80 miles. For us, 1 gallon of diesel, we can move 1 ton of freight 470 miles.
That's incredible. So Dr. Miller has a question. What is your preferred engine manufacturer? Is it GE?
Good question. Back when I was in the mechanical department, there were two manufacturers: EMD, Electromotive Division, and then General Electric. Those were the two manufacturers. We preferred EMD at the time, and that's all the way through probably about 1995. GE did a real good thing. They wanted to get their foot in the door with us, or with all railroads, but us in particular, because I worked for NS at that time. They kind of did what Hewlett Packard does with their printers. The printer's really cheap, but the ink is expensive. The locomotives were relatively cheap. Let's say they priced them down around $1 million at that time. Of course, parts were really expensive, but new locomotive doesn't need too many parts for a few years, just like an automobile. Their new locomotives, which were -9s, the models, they were pretty sorry. And of course, that's why we didn't do much GE. We did mostly EMD. But and it was Bob Lynch. I worked for Bob Lynch at that time. Me and Bob Lynch worked with General Electric. We actually rode trains. We instrumented trains. We actually got into the gory details, and they found several software flaws that came over from some of their older locomotives. They actually, it was mostly software, thank goodness. There were a few component defects, and we took their locomotives, working with General Electric, from the worst to the best in 18 months. And we have purchased probably, let's see, over 1,000, maybe even 1,300 GE locomotives since then. So probably 95. It used to be mostly EMD, but starting in the mid 90s, once we got the GE locomotive straightened out, it's probably been 90% GE. So we flipped from EMD to GE.
Dr. Banks has a great question, if I say so myself, because I'm teaching numerical methods this fall right now, and currently my students are working on homework on optimization. And Dr. Banks's question is, it seems most of your automation tasks involve some kind of numerical optimization. Do you need exotic methods, or do you end up using pretty common methods students might learn in their numerical methods class?
Let's see. Good question. I don't know that I've done anything exotic. One of the things, we actually had a system, it was the first of its type in the world. It was called algorithmic blocking and classification. And we actually worked with a company out of Princeton, New Jersey. Of course, as you might imagine, there's some smart people up there. They used the Dijkstra algorithm for actually solving the least cost path for routing rail cars. So and that was actually back in the mid 90s when that came along. I started out in OR for 2 years, and they did that type of work there. Most of the stuff that I've done, I use the simplex method because some of this stuff was, straight up linear programming and things like that. Let's see, I've done quite a bit with numerical simulation. So as far as exotic methods, I would say not. Now we do have a data science group now, MAE, MAE, and he's a PhD in data science. I call him Mabs for short. Really good guy. They do quite a bit of numerical data science, but also looking at patterns and data. For instance, one of the use cases we got them turned on to, hey, whenever you crank a locomotive, look at the voltage drop coming out of the battery. It's a 72-volt system. Well, eventually, when it drops deep enough, you're probably really close to needing a new set of batteries. So in that case, we actually use data science. And when it detects that really deep voltage drop on an engine crank, it fires up a work order, and that set of batteries will get changed within a few weeks. So they're also working on machine vision as well, perhaps automating. So any of that, some of those would probably be neural networks and things like that. I actually have taken some data science classes and actually written code for neural networks and other methods. I probably the most complex algorithms are probably over there in the data science group, where they're doing the convoluted and neural networks and stuff like that for picking up patterns that the humans could never pick up.
Okay, very, very cool. I especially appreciated your story about writing a program to automate the process of I think it was to do with dispatching, and because students I've noticed are not fans of programming, but so thank you for emphasizing the importance of that.
I can't. I'll tell you this. I'm a mechanical engineer. And my first job out of graduate school at Georgia Tech, I worked at Georgia Tech Research Institute. I focused on thermal science, fluid mechanics. I actually took a lot of aerospace courses. So I did a lot of that stuff. And at the time, President Reagan was the guy, and he came up with Star Wars. And we actually had the last phase of that, the endo-atmospheric interceptor. And I wrote all of my own code to do the numerical calculations on a Mach 5 missile. To go up to about 80 to 100,000 feet and intercept a warhead. I was just fortunate to be allowed to do that. You get to be a really good programmer there. Eventually, I flipped over to Visual Basic and Basic and that type of stuff, VB script. Because I was able to, back to the quote that I said earlier, for every large project that IT does, there's 100 little ones that they'll never do. So I was able to solve my own problems that 99% of people at the railroad can't do. So I wholeheartedly recommend, even if you take one class, learning to program, because someday you're going to come across something, be it numerical or otherwise processing, that you'll be able to solve. And maybe you only get it as good as a prototype, but then IT recognizes as something that they should take on and make it a production system, and that type of stuff happens. Back to the EOT, the end of train device management system, I used Microsoft Access coupled with VB script and a HTML page. And you could put in your yard code, and it would show you all of your inventory. Okay, we had nothing like that before. Now we have visibility into the location of EOTs. I also, and actually someone else helped me do this, I couldn't do it. We talked to UPS about shipping the EOTs via their network. We integrated their shipping API, so you could say, I want to ship it from here to here, because sometimes you need to move EOTs either to the shop to get fixed, or you have locations that end up being surplus, get a lot of EOTs in by the end of the week. You need to ship them to other locations that are deficit. So you actually put in the from to, and it spit out the barcode on a piece of paper, and you taped it to the EOT, and off it went on UPS. So we solved a problem, and that system is in place to this day, 20 years later. And they're actually working on converting it to SAP now. So learn the program. I'm telling you, you'll be able to do stuff that 99.9% of the people at your company can't do. Okay. and you'll make yourself famous that way, and you'll make a ton of money. I'm speaking from experience. Okay.
Thank you, because you know, we as faculty we try to tell the students these things and they don't believe us,
Yeah.
but it always hits differently when someone such as yourself comes and says it. So thank you
Right.
for that.
Yeah. I'll brag on my daughter. After her junior year, I gave her a book on Python. I didn't know Python even existed until I looked it up. I gave her that book. Well, I changed her from psychology major to computer science.
All right,
Okay.
very
So,
cool.
and she started out making 120 grand a year.
Woo,
So,
that's right.
you can make yourself famous being able to program your own solutions.
All right, well, congratulations to your daughter. That's awesome. Dr. Banks has another question. So you may have heard UF is going crazy over AI and machine learning with a big collaboration with NVIDIA. And
Yes.
is Norfolk Southern already using AI and machine learning in your automation, or are you planning to?
Um, let's see. The snow melter thing, that was pretty basic. You pull the weather every 15 minutes, you run it against a set of rules, you turn the melters off and on. The track inspection thing, that's going to be, we're going to put an NVIDIA GPU out there on the small trailer that we tow behind the high rail vehicle, and we're going to do edge compute. You know, when you find broken rail, you need to know right now. So that's an edge compute thing. Some of it you don't have to, you know, like tie decay, that's post process. So um, yes, now we do have our own data scientists. Of course, they have a huge backlog. You know, when you have 6 data scientists and you got all kinds of ideas coming along, you can't do it in less than a year. So yes, that is starting to take hold. As far as a pilotless locomotive, well, you need a set of eyes. Not necessarily, if you do pilotless, it won't be a human set of eyes, but essentially be, you know, infrared, optical. You'll classify, hey, there's a person standing too close to the rail, blow the horn, that type of stuff. So yes, that kind of stuff has gotten to be really important for us here in the last year or two.
Okay.
Uh,
Uh, we have a question from Shankar Anand. Is precision railroading good for all stakeholders?
oh, good question. We call that PSR, right? Uh, and Hunter Harrison brought that from actually he's a American who went to Canada and actually refined it up there with the Canadian railroads, and then brought it to CSX. And then we hired one of his former disciples. So yes, PSR instills process discipline that we did not have. And they did. There are some operating plan changes and some operational changes, but it's essentially being committed to going as fast as you can, moving cars, helping them make connections to essentially get that you know, original trip plan metric that I mentioned earlier up higher. So PSR is good stuff. As far as all stakeholders, uh, one thing that is part of PSR is we tended to run an auto rack train as an auto rack train. A merchandise train is a merchandise train. An intermodal train is an intermodal train. We actually combine those. So we probably reduced 10 to 15, 10 to 20% of our trains because we actually ran an intermodal train also towing auto racks. Okay, that was a no-no before, which in reality, that was an unnecessary no-no. So that reduced the need for engineers and conductors in places. So there were some casualties, meaning that we furloughed engineers and conductors because there's a lot of efficiency gains with PSR, precision scheduled railroading. So from a operational discipline sense, it is a very good thing, but we did reduce headcount in some areas, so that was a little bit of a negative there. Okay.
Okay, so we have a lot of questions. I have one of my own though. So you've been, I think you had joined Norfolk Southern in 1991, if I recall correctly.
Mm-hmm.
So what maybe inspired you to move into railroads? And when you graduated, would you have imagined that you'd kind of be where you are now?
No. When I finished at Georgia Tech, I went to work for GTRI for 4 years, and I did a lot of computational stuff. I mentioned that earlier, and I enjoyed that quite a bit. Um, but I kind of got tired of it, so I actually took about a 2 year or a year and a half hiatus. I learned to survey, so I actually did civil engineering survey. Of course, that was like a safari for a guy who was like 24 years old, right? I enjoyed doing that. It was an outdoors thing. Um, let's see. Let's see. What was I going to say there? Then I realized that's when I got all my pilot's licenses. Then I realized I felt like I was really goofing off, and I thought, I need to get back to work. I actually taught physics at a college near Atlanta, and I enjoyed doing that. My mom was a school teacher, so that was kind of in me. But then I realized I needed to go back to work, so I applied for Lockheed at that time. They were just starting up with the F-22 project, that stealth fighter. I applied at John Hopkins Applied Physics Laboratory, got an offer there, and a few other companies. But I also thought I went through the Georgia Tech Career Placement Center since I live near Atlanta, and they hooked me up with a railroad. And no, I never imagined myself working for a railroad, but once I went to the interview and saw all the possibilities there, I was fascinated with it. And I turned down the other offers and went to work for the railroad. And of course, I had no idea, um, I'd end up where I ended up, both professionally as a director and, monetarily making money. So maybe I was
Okay.
lucky.
Yeah. Well, luck, what did they say? Luck is the intersection of opportunity and preparedness. So,
That's right.
uh,
It's better
so
to be good and lucky.
yeah, yes, better to be good and lucky.
Mm-hmm.
Um, all right, so we're running up against the clock here. So I would be remiss. I have one more question for you. So my family has had Gator football season tickets since 1982, your senior season.
My senior
And
season, yes.
I actually asked my dad when I was asked to do this. I said, "Hey, does the name Dan Plonk mean anything to you?" And he said, "I can still hear Coach Pell saying his name on the Sunday show after the game." And
Yeah.
so, what would be your favorite, maybe your most meaningful memory as a Gator football player?
Oh gosh.
Because you were part
Um,
of the real change in the culture of Gator football.
uh, Absolutely. Those were tough times at Florida. Um, actually, Coach Dickey was the guy that recruited me, and then he got replaced at at the after the '78 season, and Coach Pell came in from Clemson, and I was in his first signing class. Let's see, my most memorable. Uh, well, starting as a freshman, that was pretty memorable. Um, my first game was actually in the Houston Astrodome. Actually, my first and last game. We played University of Houston as a freshman. My first game, my last game was in a bowl game in the Astrodome. Of course, the Astrodome's not there anymore. Um, um, I guess I was, believe it or not, I was fortunate enough to be named Offensive Player of the Game 3 times over those 4 years, which was pretty good for an offensive lineman. Normally that would go to somebody like Chris Collinsworth, being a wide receiver. Probably my most memorable, probably my sophomore year, when we won the Tangerine Bowl, um, which is only 40 miles from my house and there in the Merritt Island, which is where I'm from. And then, of course, my last home game that was pretty tough to take. So those two, winning the Tangerine Bowl and then my last game in the Gator Stadium. Those would probably be the two that I remember the most.
Right, thank you. Okay,
Uh,
that I said that was the last question, but that actually sparked one more for me that I think would be a great end. Um,
okay.
because I try to instill in my students, the spirit of the Gator Nation, and I tell them
Mm,
that being a Gator is a real special thing. It really is an international entity, and
yes.
it's like the Force. It binds us together
Hmm.
and surrounds us. And so maybe could you just end by maybe speaking about what it means to you to be a Gator? I know you have degrees from 3 institutions, but could you maybe talk about being a
Oh,
Gator?
well, yeah. Let me say first, straight up, that my allegiance is though I do give money to the other schools. There's more that comes to UF, of course. Just seeing somebody randomly that has a Gator tag or a Gator hat, I have no problem going up and introducing myself to them. Uh, just bumping into um, I bumped into a guy. He was actually a judge in Brevard County, and when I introduced myself to him, he said, "Hey, your first season as a freshman was my last year of law school." And just that kind of camaraderie that exists there. I will say, even at the railroad, and there's probably 10 of us at the railroad who are UF grads, and I've been told that we are widely respected for the stuff that we do, and we are close to each other. We always are excited to see each other and be with each other. So it does mean a lot, even if I bump into somebody out in California, which there are some huge Gator clubs out there.
All right. Well, thank you so much. That concludes the Q&A session. Thank you, Dan, for a thoughtful and interesting discussion. Everyone, please make sure to join us on the next MAE Speaker Series episode. Have a great day and take care.
All
And
right,
go
thank
Gators.
you. Yes, go